Welcome to the Batch Development Environment Overview screencast for the data movement topic of the vFRA reference architecture. In this screencast, we will cover this agenda. We'll first look at importing the batch project into the Spring tool suite. Then we'll look at the copy orders job and some of the details of the master and worker implementations. And finally, some of the new Spring 3.2 features in mock MVC in particular that were used for implementing integration testing. So the first thing I'll do is import the batch project into the Spring tool suite. I'm running version 3.1. So I need to go to import existing Maven project and then navigate to the location of the vFRA batch folder. So I've selected vFRA-batch, I click open, I wait for the initial import, it shows me the list of 4 projects and I click finish. And then I wait for the import of the Maven dependencies and the build to complete and the validation to complete. The import is complete. If I go to vFRA batch core, I can see that I have the Maven dependencies downloaded. I'm using Spring Framework 3.2. And I also have a bunch of JavaScript problems that are the result of using the JQplot library. I'm going to go ahead and delete those since there's nothing we can do about those and we can just ignore them. And then finally, I will run the integration tests that are under the vFRA batch core project under source test Java. There are a bunch of tests there. I'm just going to select the project and I'm going to click run as a JUnit test. And then about 18 seconds later, I can see that all 6 tests have completed and that my import is successful and everything's working as expected. So now we're going to look at the details of the copy orders job. So from a database perspective, there is a staging database, and we're looking at the H2 database used by the integration test. In the staging database, there's an orders table, so the job will read the data in the orders table and it will write it to a reporting database, an orders table with similar schema with slightly different column names, use of underscores, and timestamp instead of date, just to show some basic transformations. We can also look at the job database, and this is the job repository or set of tables associated with the Spring Batch framework. Go back to STS and look at the copy orders context.xml file that's in the vFRA batch core project. We have a copy orders job, and it has a single step that uses an order item reader and order item writer, typical Spring Batch pattern of having out-of-the-box item readers and writers configured and wired together. In the case of the reader, we are using the JDBC paging item reader, and we configure the select statement via these properties. In the case of the writer, we're using a JDBC batch item writer, and here you can see we're configuring the insert statement into the reporting orders table. And in addition, we have an order row mapper, which handles some of the transformations I mentioned earlier. Now we're going to look at the master and worker implementations. And so the master polling partition handler, which again is in the vFRA batch core project, is our point of customization for the master logic. So there's a handle method that implements a Spring Batch framework interface that's responsible for splitting the input. So that's done by the split method via the step execution splitter. That's where we're calling our column-based, primary key-based row partitioner. And then we are calling for each partition that we create a run step execution method, which is an interface method on our remote step execution service. And the implementation is based on REST template, so that will be converted to a REST template put method. And then we have a poller, which is configured, and these are all auto-wired we have a poller that will poll for status, and this will continue to poll for each partition to complete within the time frame allotted by the max poll time parameter. And then finally, once the polling completes, the job will, or rather the step execution will complete and return from the handle method. Now if I look at the worker implementation classes, we have the worker controller. The worker controller is a Spring MVC controller. It uses some of the Spring MVC annotations. You can see here we have request mapping for the worker controller class, and we have a request mapping for this particular method, run step execution, and that's our REST call, and here is our REST URI. You can see that we are going to parse the job execution ID, step ID, and step name using the path variable annotations. And so the framework will take care of copying those values from the call into the method parameters. And then from there, we are calling the handle method on our step execution request handler. And because the handle method implementation from the worker request handler class uses the async annotation from the Spring framework, that handle method will be executed in a separate thread pool, which is the worker task executor thread pool, so that the worker controller can return immediately to the master. The master can continue to call other workers in the cluster. The handle method is responsible for calling the step execute method of the Spring framework. It passes it the step execution, and then the execute method will read the step configuration that we looked at earlier and execute the item reader and writer. So now I'd like to talk about integration testing and some of the Spring Framework 3.2 features that were used, as well as the support within Spring Batch. So the first test we'll look at is called Worker Controller Test. And in this case, I'm using a new annotation called Web App Configuration. That's part of 3.2. And I'm using a mock MVC object, building that mock MVC object based on the web application context that I supply, and that is auto-wired by the test framework. So what this means is that I'm able to essentially build a mock servlet environment to run my controller in. I don't need an embedded servlet container like Jetty or Winston, and I can build my controller and dispatch requests to it based on the same configuration I would use in a real embedded servlet container. So in this case, I'm using the context configuration annotation to supply a servlet context.xml, which I would normally do in a web.xml file. So I can run my controller with the exact same configuration. In this case, I am testing the worker controller, and so I built in my application context, I'm able to get a hold of the worker controller, which is what I'm doing here, and I'm going to override the step execution request handler to provide a essentially empty implementation so that it does not interact at all with the H2 database and the job repository. So I'm basically removing that from the equation. In my test controller test method, I'm also highlighting the ability with a mock MVC object to do a perform of a put request and even supply accept headers and validate or assert what's expected from the response. So in this case, I'm expecting that the status is accepted. I'm expecting a certain content type from the response, and I can even assert certain things about the content. For example, in this case, that the string is exactly what's returned by my master controller. And if you were dealing with JSON, you could even go further and assert that certain elements of your JSON were as expected as well. So this is a very powerful means to test a REST API. So the next test we'll look at is REST template test. Now this test is using a new feature that was just implemented in 3.2, and it was implemented by the lead for the Spring MVC test project, Rasin Stoyanchev. And in fact, I was at Spring 1 listening to his presentation on some of the new test features. I went to him after the presentation and said, oh, this is all very cool, but I've got this case where I have a REST template talking to a Spring MVC controller, and wouldn't it be cool if I could get that template to talk directly to this mock servlet environment? And he said, oh, that's a good idea. And he went ahead and he implemented that, and this is the result. I can now pass a mock MVC object to a request factory, pass that to a REST template, and now when I make a call to this REST template, it's going to be directed to my mock servlet environment, and it will be dispatched to a controller that's available in that environment. In this case, this controller that has this particular request mapping. So that's a very cool feature if you're using REST templates and Spring MVC within the same context as I am. I'm using a REST template on the master side, Spring MVC on the worker side. So I'm able to actually, you'll see in the next test, I'm able to bring this all together in a way that avoids all of the overhead of a embedded servlet. So in the successful step test, we put together all of our building blocks, and first of all, we're using a job launcher test utils to load the configuration for our copy orders job and then run the job. And after the job completes, again, we are using H2, so we expect that in the reporting database, for example, we have certain orders of a certain type that should have been copied there, so we can validate that. We can also validate that in the job repository that the status is completed for the job. And then in addition, we're following on our previous examples of using a web application context and initializing our mock servlet environment. With that application context, we are wiring up a REST template as we did before, and we're setting the REST template on our REST step execution service that's used by the master partition handler. When we actually launch our job, it's going to make calls through that REST template to worker controller, which will be wired as the result of this context configuration annotation, which is by default associated with an XML file of the same name of the class -context. So if I look here, you can see that here is where I'm actually loading the servlet context that's included in the web application context. And then I also have this context file that sets up the H2 databases for me and initializes them. Also sets up that test utils object. As you can see, we have a lot of great tools to build an integration test, and particularly relevant in this case where we have a fairly complex set of interactions on the master and worker side. We have a layer of custom code. We have the framework for Spring Batch involved, interacting with the repository, a lot of moving parts, and with successful step integration test, we can test all those moving parts together in a very efficient test. So that concludes the development environment overview screencast. Thanks for listening.